Today, we're looking at something pretty exciting, a potential breakthrough in Blu-ray storage.
Yeah, this comes from research out of Shanghai, the University for Science and Technology, and the Institute of Optics and Fine Mechanics.
Right, and this isn't just a small step, is it? They're talking about a big leap forward. If you're thinking about storage, maybe for work, maybe photos, this could be huge.
Definitely. It's a fundamental shift, potentially.
Yeah.
So our mission today is to unpack what these advancements are and, what they could actually mean for you.
Okay, let's get into it. The core idea seems to be this: 3D nanoscale optical storage.
Exactly. Think layers, but incredibly tiny and stack really close together.
So not like the layers on a current disk, much, much smaller.
Way smaller. We're talking nanoscale.
Mm-hmm.
And the key to doing this is a special material. It's called, let me get this right, aggregation-induced emission dye-doped photoresist.
Okay, AIE DDPR for short, maybe.
Let's go with that. AIE DDPR. Its properties are what allow data encoding at this super small scale when light interacts with it.
And how do they actually read the data that small? You mentioned light.
They've developed a really clever dual laser system.
Dual lasers, okay.
Yeah. So you have two lasers working together. Think of one laser sort of initiating the recording on the AIE material, and the second one controlling or inhibiting the process around that point.
Ah, I see. So one writes, one sculpts, kind of.
That's a good way to put it. It allows for incredibly precise, tiny recording spots, much smaller than conventional methods. They use specific wavelengths and intensities, all very controlled.
And this lets them stack layers incredibly close together.
That's the key. Up to 100 layers in the same space a normal disk uses for just a few. And these layers are only separated by about a micrometer.
1 micrometer, that's tiny.
It really is. And that density unlocks, well, frankly, jaw-dropping capacity.
Okay, hit me with the numbers. What are we talking compared to, say, a standard Blu-ray?
All right, so a standard Blu-ray, maybe 50 gigabytes, dual layer. This new tech, they're talking up to 1.6 petabits on one disk.
Petabits? Wait, how much is that in terabytes?
That translates to roughly 200 terabytes.
200 terabytes on one disk.
Yep. Compare that 50 gigabytes to 200 terabytes. It's like a 4,000 times increase.
Wow, that's the leap you were talking about. Okay.
It really is. Suddenly, you can think about storing enormous data sets, entire archives, on just a few disks.
You'd imagine creating something that dense must take forever, right? Layer by layer.
That's what you'd think. But the research suggests the fabrication process is surprisingly fast.
How fast?
Around 6 minutes, from coating the disk material to encoding all that data across the layers.
6 minutes for 200 terabytes.
Apparently so. That speed is, well, it's really crucial if you're thinking about mass production. It suggests it could be scalable.
Okay, capacity is one thing, speed is another. But what about keeping the data safe? If I put 200 terabytes of precious data on there?
Good question. And another strong point, it seems. The material and structure offer pretty robust protection.
Against what? Like dropping it?
Well, maybe not dropping it, but definitely against environmental factors, humidity, temperature changes, even electromagnetic fields that can sometimes corrupt other media.
Okay, that's important for long-term storage.
Absolutely.
Yeah.
And they're projecting a data lifespan of over 100 years.
A century? Wow.
Plus, it's meant to be quite energy efficient compared to, say, large server farms or constantly spinning hard drives for archival. Lower power consumption.
So massive capacity, durable, long-lasting, energy efficient. Sounds great, but is it just a lab marvel, or could we actually see this?
That's perhaps one of the most practical aspects. The technology is designed to be compatible with existing DVD manufacturing infrastructure.
Really? So factories that make DVDs now could potentially adapt.
That seems to be the goal.
Yeah.
It dramatically lowers the barrier to entry,
Yeah.
makes commercial adoption seem much more feasible, maybe even cost-effective down the line.
Okay, so let's recap the big picture here. We've got a new Blu-ray type tech using nanoscale 3D storage.
Right, with that AIE DDPR material and dual lasers.
Achieving absolute massive capacity. It's like 200 terabytes per disk.
A 4,000-fold increase, roughly.
Plus, it's durable, potentially lasting over 100 years, energy efficient, and crucially, might actually be manufacturable using current setups.
Exactly. It ticks a lot of boxes for addressing the huge and growing need for data storage globally. It's that combination of capacity, longevity, and potential practicality.
It really feels like a significant step. Okay, this has been a fascinating deep dive.
It's definitely technology worth watching.
So for everyone listening, here's something to think about. If you had access to storage that could hold almost unimaginable amounts of data, last for generations, and do it efficiently, what does that unlock for you? Think about personal archives, family history in detail we can't even imagine now, or scientific research dealing with colossal data sets, or even for creatives, storing massive project files safely forever. What new things become possible when storage basically becomes unlimited and permanent?
It opens up a lot of possibilities.
Definitely something to ponder. Thanks for joining us on the deep dive.